Toshiba Electronic Devices and Storage Corporation. E-learning. Basic knowledge of discrete semiconductor device. Chapter 1. Basis of semiconductors. This video will explain the basics of semiconductors like definitions, materials, Ntype, P-type and PN junction. What is a semiconductor? A semiconductor is a substance with characteristics intermediate between those of a conductor that conducts electricity like metal and an insulator, through which electricity hardly flows. The ease with which electricity flows is related to the magnitude of the substance's electrical resistance. If the electrical resistance is high, the current hardly flows, and if the electrical resistance is low, the electric current flows easily. When electrical conductivity is expressed by resistivity, semiconductors are distributed in the range of 10 to the -4 to 10 to the 8 ohm centimeter, whereas conductors are 10 to the -8 to 10 to the 4 ohm centimeter and insulators are 10 to the 8 to 10 to the 18 ohm centimeter. Semiconductor materials. Silicon and germanium are well-known semiconductor materials. When they are pure crystals, these substances are close to insulators, intrinsic semiconductors, but doping a small amount of dopant causes the electrical resistance to drop greatly, turning them into conductors. Depending on the kind of dopant, N-type or P-type semiconductor can be made. Semiconductors made of several elements are called compound semiconductors, as opposed to those made of a single element such as silicon semiconductors. There are combinations such as Group 3 and Group 5 of the periodic table, Group 2 and Group 6, Group 4, etc. Ntype Semiconductor. What is an Ntype Semiconductor? An Ntype Semiconductor is an intrinsic semiconductor doped with phosphorus, arsenic, or antimony as an impurity. Silicon of group If has 4 valence electrons and phosphorus of group V has 5 valence electrons. If a small amount of phosphorus is added to a pure silicon crystal, one of the valence electrons of phosphorus becomes free to move around as a surplus electron. This is called free electron. When this free electron is attracted to the plus electrode and moves, current flows. P-type semiconductor. What is a P-type semiconductor? A P-type semiconductor is an intrinsic semiconductor doped with boron or indium. Silicon of group 4 has 4 valence electrons and boron of group 3 has 3 valence electrons. If a small amount of boron is doped to a single crystal of silicon, valence electrons will be insufficient at one position to bond silicon and boron, resulting in holes that lack electrons. When a voltage is applied in this state, the neighboring electrons move to the hole, so that the place where an electron was present becomes a new hole, and the holes appear to move to the minus electrode in sequence. What is a compound semiconductor? Apart from silicon, there are compound semiconductors that combine group 3 and 5 elements and group 2 and 6 elements. For example, gallium arsenide, indium phosphide, indium gallium aluminium phosphide, etc. have been conventionally used for high-frequency devices and optical devices. In recent years, indium gallium nitride has been attracting attention as a material for blue LEDs and laser diodes, and silicon carbide and gallium nitride as materials for power semiconductors have been noted and commercialized. What is a PN junction? The contact surface between a P-type and an N-type semiconductor is called the PN junction. When P-type and N-type semiconductors are bonded, holes and free electrons, which are carriers, are attracted and bound and disappear near the boundary. Since there are no carriers in this area, it is called the depletion layer and it is in the same state as an insulator. In this state, connecting the plus pole to the P-type region, connecting the minus pole to the N-type region and applying a voltage cause electrons to flow sequentially from the N-type to the P-type region. The electrons will first disappear by combining with holes, but excess electrons move to the plus pole and current will flow. Types of semiconductor devices. Electronic parts using semiconductors are called semiconductor devices. Many kinds of semiconductor devices have been developed in line with the expansion of application fields and the progress of electronic equipment. Discrete semiconductors are single devices with a single function, such as transistors and diodes. Integrated circuits (ICs) are devices with multiple functional elements mounted on one chip. Typical ICs include memories, microprocessors, MPUs, and logic ICs. LS I raised the degree of integration of ICs. Classification by general function and structure is shown below.